Hi, this is Susie Oliver with TCC. I am going to go over program 8 today, the inventory program with comma-delimited input. Okay, create an inventory program that will accept a string from the user that contains values separated by commas. Alternatively, you may paste the input into the program as a string literal in between quotes, which is what we'll be doing today. In the future, do not hard code data into your programs in this manner without explicit permission from your instructor. Doing that's fine for development and early testing, but it's not done in the real world after the first phase, so you should not normally be submitting assignments that still have hard-coded data. I'm making an exception this one time because the string you need to type is so long and it's almost impossible to do so without making a mistake, and even copying and pasting is a hassle. In the real world, we'd probably read this from a file. Okay, so we've got, this is what the input looks like. CDR 100 disk, comma, and then some spaces, 25, and then 14.00, DVD-R 50 disk, etc. The first several values, that one, the 25, the 14, all are related to each other. This is the item name, or the product name, and this is the quantity on hand. This is the cost per item, and then here we've got another product, and quantity on hand, cost per item. Product, quantity on hand for 12, and then cost per item 4, and so forth. And so we need to split this up once we've got it into, once we do a split and get it all in one long list, we need to split it into 3 lists. And the first list is going to be products, and then quantities, and then costs. Okay? The 0th element for products will be this one, and then the 0th element for quantities will be the 25. The 0th element for costs will be 14. Okay? And then we'll have the next one in there. So we'll have 3 lists whose subscripts all, if they're the same subscript, they relate to the same item. So it's going to look something like this. We'll have the products, say this is the product list, and then this is the quantities list, and this is a cost list. You're going to calculate the total cost. And then you'll also calculate the grand total cost. Okay, you're going to split strings into a list. We'll be splitting them on the commas. We're using what's called comma-delimited data. All of the pieces of data are separated with commas. So you see you've got this name, and then a comma, and then some spaces, and then the 25 and a comma, and then some spaces, and then the cost, and another space, and a comma. So the commas are separating each piece of data. So if we do a split, which is a function that you can do on a string, and it will turn it into a list, and it will put each item of data into its own element. Now remember, there's still going to be strings at that point, so we'll have to deal with that later and turn quantities into integers and the costs into floating points. Okay, we'll be doing some other string parsing techniques. We'll have to get rid of those spaces. We had leading and trailing spaces on things. And we're going to learn to do slice lists. Basically, we're splitting up the list. We're going to have this long list that has everything together, and then we're going to go in and grab the 0th element and put it into the products, and then we'll grab sub 0, and then we'll grab sub 3, and then sub 6, and so forth, to make up our products list. And then we're going to get element 1 and element 4 and 7 and so on to get the quantities list. And then we'll have to do element 2, and then plus 3 is 5, plus 3 is 8, and so on, to get the costs list. And so that's known as list slicing. We're going to use list comprehension to help us do our string slicing. Create and call function named main, and I've already done that. I'll show it to you in a second. Within main, greet the user with a short description of the program, such as welcome to the inventory system, and skip a line. Get this to work before moving on. So let's go ahead and copy that. And again, copying from a Word document or a PDF is a little bit dangerous. because of hidden characters and also quotes. I deliberately use straight quotes here, which are fine. But some teachers might use curly quotes, and then you're in trouble because your program's going to blow up if you use those. So I've already got the comment section filled out, and I've got my main defined, and I've called main and all that. So I'm going to greet the user here. Alright, now we're going to accept a string from the user, number 3, or hard code the string into your code, and we're going to hard code it. This string is comma-delimited input for the inventory of a small computer store. Notice every item has a comma after it. A comma, 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 comma. Also notice we've got some leading and trailing spaces in between some of these, and we'll see how that plays out in a minute. Okay, I'm going to copy this string and hard code it in, and I'll call it user input. Or let's just call it input string. Input string equal quote. Okay, I'm just going to let it, this is the 80 character mark. It's going to give me a warning because I went past it, but that's okay. Alright, number 4, parse this string and store the items in such a way that you can make the table farther down. Here's my advice. A, split up the input string into a list of strings at the commas using the split function. Okay, let's go do that. Okay, so I'm going to call it items equal, and then, so items is going to be a list, and it's going to split all of this string at the commas. It's not going to keep the commas though, so I'm going to say input string, string dot split, and then quote comma. So that's going to split it at the commas. And I'm going to print that to make sure it's doing what I think it's supposed to do. Okay, so it is. It's splitting them all up. Notice everything's a string, including the numbers. So we'll have to deal with that later. B, then make 3 new lists for products, quantities, and costs from that list. These are called parallel lists because they each have the same number of elements and because each index refers to the same item. So if you've got product sub 0 and quantity sub 0 and cost sub 0, they all relate to the same item in inventory. And we can use list slicing. The third argument is going to be a 3 because every third one is the same thing. So products sub 0 or items sub 0 and items sub 3 and items sub 6 and so forth are all products. And then items sub 1, 4, 7 and so forth are all quantities. Now you could go through a loop and move every third item into an associated list. That would work as well. Okay, so products, those would be the names of the products, is equal to items. And we're going to start with element 0. And I'm not going to put the ending one because I want to go all the way to the end. And then I'm going to get every 3 of them. Okay, then I'm going to print products to make sure it's doing what I think it's supposed to. Okay, yeah, we've got the products names. Notice we've still got the leading spaces here and trailing spaces there, but we'll fix that a little later. Okay, we want to do this for quantities. And we'll start at element 1 and every third one. And then I'm going to print quantities. And then I'll do it for the costs. and those start at element 2. Okay, so those are our quantities and costs. Note these are still strings, and we'll deal with that in a little bit. Now we'll deal with number 5. Make sure you strip all leading and trailing spaces in the product names. The strip function will come in handy. You could use list comprehension here, or you could wait until right before you print it in the table. Since this is a learning experience, I would go for list comprehension. Okay, we're going to remove leading and trailing spaces from products. I'm going to say products equal, and then we have to have square brackets to do list comprehension. I kind of like to start with the for part of it first and then go back. So we'll say for product singular in products plural, and then go back to the beginning and say product strip print like that. Okay, and then let's move this print statement down there. To make sure it's working right. Okay, and it stripped all of the leading and trailing spaces. Notice the spaces in the middle are still there. After the R, after the 0, those are fine. Okay, now we need to, let's look at our instructions again. Then convert the quantities to ints and the cost to floats. We're going to use list comprehension here too. I'll go ahead and say using list comprehension. Convert quantities and costs to numbers using list comprehension. Quantities equal square brackets for quantity and quantities. And then come back and say int of quantity. All right, let's print quantities. Quantities. And then let's also do costs. Costs equal square brackets float. Let's go and do our for loop. For cost in costs, and then we'll say float of cost, and then let's move our print statement down there. Okay, and let's run. Okay, so these are all numbers now, okay, which is what we wanted. Okay, so our data is in pretty good shape now. For the table, print headings, product name, quantity, cost per item, and total cost, and then skip a line. All right, I'm going to go ahead and copy that. Make that an F string. You'll see why in a minute. I'm going to put each one of these in curly braces and its own set of quotes. And the purpose for that is to get the alignment to work better. I know this looks a little strange. You're having to put the single quotes inside the double quotes here. But there is a method to the madness here. Just bear with me. Okay. Alright, now, number 8. For each new item, print the product name. If you haven't already stripped the white space on each end, do so now, but we've already done that. And print quantity, cost per item, and total cost, which is the quantity times cost per item on one row of the table. If you haven't already converted the strings to numbers, you need to do so now. We've already done that though. You could store the total cost in a list, but it would be more efficient to calculate it and use a single float variable within a loop as you print each line of the table below. I will make a reduction of 5% if you create a list for the total costs. You should calculate it right before you print it and keep a running total for the grand total. Now, I could say something like for product in products, but then I could only print the product elements. And I need the product elements and the quantities and the cost per item. So I'm going to use for I in range. And then how far do I need to go? Each one of them is the same length. So if I just do the length of products, that would be the same thing for all of them. So I'll say length products. And then my colon. And I'm going to print F string again. And I'm going to print products. Oops, I need my F on the outside. Products, sub I, because I'm getting the elements. And then I want quantities, sub I. And then costs, sub I. Okay, we'll deal with the total cost in a minute. Let's go ahead and get that working. Okay, if I run that right now, everything's jammed together. Your headers all jammed together, your data on your rows are all jammed together. Okay, so we need to figure out how long each of these things needs to be and make it line up in a table. Okay, on products, let's see what the longest one is. That would be laptop cooling pad. That's 3, 6, 9, 12, 15, 18. That's 18 long. And then product name is shorter than that. So we're going to make this, let's make it 2 longer. So instead of 18, let's make that 20. And then we're going to make its header 20. Because I need these to line up on top of each other. And then for quantities, all of those are 2 digits long. So I could make that 2 plus 2 is 4, so that would give me 2 spaces in between. Whoops, quantities longer than 4. 1, 2, 3, 4, 5, 6, 7, 8. And then plus 2 would be 10. So let's make that 10, and then change that to 10. Then on cost per item, all of those are 2 digits long in front of the decimal and should be 2 in back of the decimal, and then plus the decimal is 5. Then we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9 long. So that's longer than this. So we'll make that 9 plus 2 is 11. And then, because I want 2 spaces in between everything. So that's going to be 11. But it needs decimal points, so I'm going to say 0.2. So I have 2 digits after the decimal. And then I need the F. Okay, let's run that and see what happens. Okay, well, we're off a little bit. Now, the reason we're off is because quantity is a string and quantities is a number. Numbers are automatically right justified. Strings are automatically left justified. I need both of these to be the same justification. So to right justify this string, I need a greater than sign. Same thing on this one. Okay. Now let's try that. Hey, okay, now see it's lining up. And that's lining up. We'll deal with the total cost in a minute. All right, for total cost, I'm going to say total equal, and it was quantities times costs. So quantities, now to get the specific element, I have to say sub I, and then times costs sub I. Okay, now I can come down here and put total in. And it needs to be, when I add these up, well, when I multiply them out, I could get something like 100 or so. So I'd need 3 digits in front of the decimal place, and then 4, one more for the decimal, and then 2 more would be 6. No, 1, 2, 3, 4, 5, 6, yeah. And then this is 3, 6, 9, 10 long. Okay, so I need to make that plus 2 would be 12. So I need that one to be 12. And then 0.2f. Okay, let's look at that. Okay, I'm off a little bit. 1, 2, 3, 4, 5, 6. Oh, I need my greater than sign there. Okay, now it all lines up right, but I'm supposed to have a dollar sign right there under the T. If you'll take a look. Dollar sign there under the T. So I'm going to put dollar sign there and a space and see what that looks like. Okay, the dollar sign's jammed over here, and it needs to be under the T, so I need to move it over 1, 2, 3, 4. And if I move that over 4, and then I've got 2 more there, that's 6. That probably needs to be 6 there. Okay, that's what I wanted. Okay, now we need to do the grand total. Okay, so compute, number 9, compute the grand total value of the inventory. For the grand total, you should have a running total. You could use sum if you'd made a separate list for the totals, but the sum function is less efficient because it will have to step through the array again, and you'll have to waste space for the list unnecessarily. Add it up as you were doing the table output in the loop mentioned in the previous step, which is a more efficient manner. Remember, I'll count off 5% if you use a list for totals because that's inefficient. And it's supposed to look like that, okay? Okay, so what I need to do is say grand total plus equal total. So that's like saying grand total equal grand total plus total. Now, why is this red squiggly here? Unresolved reference grand total. I haven't used grand total before, so I can't add something to it. So I need to create it above the for loop and say grand total equal 0. I could get away with just saying 0, but it's really float, so I'll say 0.0. And then after the for loop, I need to print it. So I'm going to go even with the for, the keyword for, print f, and I'm going to paste that in there. Grand total, and that's going to be could be 4, 5, 6, 7. Get rid of that space in case I need that. 7.2f. Let's try that. No, we're off a little bit. I need to move it over 1, 2, 3. 1, 2, 3. There we go. Now, I'm supposed to have a space before that, and let's make one after it. \n, \n. Okay, there we go. Let's see, let's get rid of these extra print statements. That. And that. Okay, I've still got another one. Items is being printed. And I really should have a space here. And here. There we go. There's a nice looking table. Okay, if you have any questions, send me an email.